Depressurization. Why do we need the depressurization? When the fire occurs at the gas-filled vessel, the shell of the vessel will be exposed to the extreme heat on the outside. Not only that, the potential of the exothermic or runaway reaction of the gas-filled vessel will occur within the vessel also can cause the rapidly temperature increasing. Metal temperature may reach to the point that lost the tensile strength, resulting to the vessel rupture even though the pressure does not exceed the set point of the pressure safety valve. So the key point of considering the requirement of depressurization is the gas-filled vessel. Gas-filled vessel is not mean the pure gas vessel, but it means the vessel that does not full with the liquid. Gas portion will directly contact with the extreme heat without the absorption by the liquid. What is the objective of the depressurization? Vapor depressurizing provide means of the prevention of escalation barrier for the process unit by reducing the contained pressure. So the objective of the vapor depressurizing can be summarized as 1. To reduce the chance of the rupture of any steel pressure vessel exposed to the fire due to the metal. Strength is dependent on both pressure and temperature. So if we can reduce the pressure, that vessel life will be longer. From the picture, it shows the impact of the stress and time for the fires cover the vessel. The slope of the stress line, red line, increasing rapidly against the time, and cross the reducing the vessel strength. The time is very short. But if we have the depressurizing system, the time of the vessel can be longer, as shown in the picture. Second, to reduce the driving force of the jet frames, leakage of the liquid spill and gas leak. That means the depressurization can also reduce the hazardous impact zone. What about the PSV? PSV cannot provide continuous the depressurization due to the operation of the PSV is dependent on the rising of the pressure in emergency situation. Only by lifting a spring load is this different with the depressurizing control system, which can be provided the continuous depressurizing automatically or remotely manual by operator judgment. Where shall we place the depressurization? They have no clear requirement of placing the depressurization system in international code and standards. It depends on how the risk of the tank or vessel rupture when the fire occurs. The many external factors shall be considered together, such as the existing fire water system, fire proofing, accident history, or etc. Generally, the emergency depressurization shall be provided for process equipment contain at least 2 tons of liquefied butane or more volatile liquid under the normal operating condition to prevent the BV. Or high pressure of the flammable process unit with true vapor pressure greater than 2 bar at the 40 or 50 degrees Celsius and operating pressure more than the 30 bar G. Process unit in which have the potential of exothermic reaction can lead to loss of primary containment. However, there are some exceptions available if the presence of the mitigation provision or passive protection such as the mounted LNG bullet stored at below picture. It is undergrounded and mounted vessel application. No flank below liquid level is available. So the chance of catastrophic scenario by far is eliminated. What is the depressurizing valve? Vapor depressurizing valve may be electric motor operated valve, pneumatically operated control valves, or manual operated valves, depend on the utility available and strategy. If used pneumatic operated valves, high rate should be failed to open or de-energized to open, with the provision to maintain the pressure on the diaphragm in event of the instrument air failure to limit the outlet velocity. Second, depressurizing valve should be the type shut-off valve, means equipped with the solenoid valves. So actuator should be spring to open type. And to reduce the spooler tip, redundant solenoid valve may be applied. How to design the depressurization? First one, select the type of depressurization. The depressurizing system is classified into 2 systems, which are first one, high rate depressurizing within the 15 minutes And second one, low rate depressurizing within the 60 minutes. The endpoint of depressurizing system generally is to 7 bar or 50% of the desired pressure, which is lower within a certain time. For the good engineering judgment, the required for the selection, typical depressurization rate is based on the wall thickness, initial metal temperature, rate of heat input, and file type. Typically, low rate depressurizing is intended for operator control. It means it can be both activated by manually or automatically by using the process set point unless fully open of the low rate depressurizing valve still not able to reduce the system pressure. The low rate depressurizing valve will be replaced by opening the high rate instead. So the low rate depressurizing can be used as parallel with the high rate as shown in the picture. But it is designed for the fail close, not fail to open, to limit the flare capacity. Other consideration factors such as the vessel, which may be exposed with the jet frame impingement, is required more rapidly rate than profile. Second one, estimate the depressurization flow. When estimating the flow for the sizing, depressurizing valve, and piping, it is also important to consider the other factors such as the effect of the initial depressurizing rate on the flare system, thickness of the vessel, and depressurizing time. As shown in the picture, you can see the higher thickness of the vessel in the dotted line have more time margin than the thinner thickness of vessel. Potential of the liquid carried over to the flare that shall be considered. Potential of the brittle fracture. During the depressurizing, in the most cases, it leads to the lower temperature, lower than 0 degrees Celsius, within the equipment and its related piping. So when material exposed to the lower specific minimum design temperature, it may permanent damage or brittle failure. So the graph of depressurizing time and reducing temperature should be studied as below. You can see the rate temperature change shall be limited within the material ductility. Potential of the hydrate formation also shall be considered. The third one, consider how to activate the depressurizing. Emergency depressurizing may be initiated by the manual or by automatically of the process instrumentation, emergency shutdown system, or signal from fire and gas system. The reliability of depressurization activation system typically shall be studied in seal determination and seal verification. The picture below is the fire and gas mapping system. Voting by fire and gas system is one of initiator in the process. This is the basic information of depressurizing system. Thank you for watching my video and let's see on next video. Bye bye.